data structures using C. During this lecture, you will understand how to implement circular queue linked list version. So you will understand, we will work on that, study the algorithm, and then write functions relating to that, to insert, to delete, etc. From the items from a circular queue. Here is the circular queue. Linked list version, as you remember, this is a front, and this one is linked to the next node and goes on like this circularly, and the last rear node is linked to the front node. Therefore it's called the circular queue linked list version. We have done the circular queue array version, which is a little complicated. This is much far better version of implementation of the circular queue. Let us see. We'll start with again the node of the circular queue. It contains a data item called number variable and a link to the next node, only that as we have done earlier, very similar. So now let us see how to declare a new data type called circular queue node. Again contains number, and here you have got the pointer to the next, which will store the address of the next node. And this is the new data type. Now we create a pointer variable called node, saying that circular queue node star node. This is node is going to be a pointer variable, and this is how we allocate memory. You are very familiar with this. Saying so, circular star malloc size of circular queue node. Of course, semicolon has to be there, and then here I assign 70 to this number, this variable in node, and always we do this, we point the next to null, so that is grounded. So this is how it is going to be, very similar to the other nodes, list nodes, etc. we have created. So then we have the function make circular queue node out of these number. Again we allocate memory here and assign that number to this node number, and return, this is very important, return the address of this node which we have created, node of the circular queue. So here, for example, circular queue node, I say node is equal to make circular queue node out of 20, and automatically this node here, this variable node now contains the address of this node circular of the circular queue, which contains 20 as the data item, and it is grounded, it points to null. So this is always we have been doing this. We have written a function to create the node of, in this case, circular queue. So now with that we come to the implementation of circular linked list. Let us go through the algorithm, how to create circular linked list. Circular queue, it is not circular linked list, circular queue. So as you see, we have explained, it is front and the rear, and rear is linked to the front. So let us see various cases, circular queue. So what we are going to do in this case is, we are going to create two pointer variables called front and rear as global variables. We are not going to pass them to each of these functions. They are global variables. So that is very important. So front and the rear, and then we are going to assign them, assign null to them, or we initialize these two to null at the beginning itself, or at the beginning of the program. You will see we'll write one more function called init circular queue. So in that we are going to make these two null, and also we are going to have one more variable capacity. We will assign 0 to that when we initialize the circular queue list. So we will get into now. Case 1, there is no list. Always case 1 has been either there is no list, or there is no queue, or there is no stack, etc. So here we say there is no list. How do I know that there is no queue existing? So very simple. If check whether the rear of the circular queue is null. So I ask this, if the rear of the rear is null, make the incoming node front and rear of the circular queue. That is what we are going to do. I'm creating a new node out of 30. Then I ask this question, if rear is equal to null, front and rear are equal to new node. So I'm assigning that or making that new node the front and rear and return. That is what we are going to do. Okay. So with that we come to case 2. There is a circular queue. Attach the next node to the rear. That is what. So rear is there. I attach always the new node to the rear. Very simple therefore. Then make the incoming node the rear of the list. How to do that? So that to do that, so I have got the pointer to the rear. So I just say rear next is equal to new node or assign new node to rear next. That is what we are going to do. For example, here we have created a new node out of 12. Then I say rear next is equal to new node. And this is very important. Then you say rear is equal to now new node has been attached at the end. Till this was the rear. So I am going to therefore make this new node the rear of the list. And of course this is very important. Then what I do is I connect. Till then it was the old rear which was connected to the front. Then I say rear next is equal to front. I will show graphically here. So here, for example, I say rear next is equal to new node. I have created a new node. So new node 85 is there. So rear next here is assigned the address of the new node. Then what do we do? Rear is equal to new node. So so rear becomes the new node, that is, so new node has become the rear. Earlier this was the rear, now this has become the rear. Now next is I say rear next is equal to front. I am linking this rear next with the front, so this is severed. Now the new node, which is the rear, which was attached to the end of the earlier rear, has become the present rear, and it is linked to the front of the circular queue. This is what. So this is the uh, function enqueue number. So I've got these local variables. I'm making a new node out of this number. Then I ask this question, if rear is equal to null, front and rear, you assign new node to front and rear, and make the capacity, because now there is one node, make the capacity 1. Or otherwise, if there is already a list, then I say I attach the new node to the end of rear next, then make that new node the rear and increment the value of capacity and come out of this, and then I say rear next is equal to front, or link the rear with the front. So this is the uh, function called enqueue to insert a node at the rear of the queue. Now we come to the deleting of the first node. Always we know it is first in, first out, first in F5, first in, first out. So first is always removed. So let us see how. Now this is the front and this is the rear. So now we have to delete, dequeue has to be done. So that means we have to remove this. So what do I do? Therefore, first I assign this front to a variable called current. Then I have to get this number. So this has become current. Then I say number is equal to front number or current number. So immediately this 20 is placed in this variable called number. Then what do I do? Now I have to remove this. I have to attach rear to this. So what do? I say front is equal to current next. So now front is here, current next is the address of this. So this is what I do. Front is equal to current next. And now I have to link these. So that is front is equal to current next. Now rear next, this is rear next is equal to front. The new front is there. So I have to link this. So this is what is happening. So rear next has become this node now front. Now free this node has to be freed. I free that node, that is removed. Now this is the new front and this rear is attached to the new front. So that is how we delete a node from a queue. So here is the code for that. Dequeue. So it returns. So I have declared what is a variable called current. I've got number. If capacity is equal to 0, that means there is no item in this queue. So then I assign null to front and rear, and I return -1 in my uh, program. Then if front is equal to rear, that means there is one node, both of them, capacity is equal to 1. Then I remove this node from the front, free the front. I say capacity is equal to 0. That is because there is no item in the list queue. And then I assign null to front and rear. Very important, because if the front and rear are null, I know that the queue is empty, and then I return number, because I've deleted just one number which was present. I've deleted that, and then number. Otherwise, what do you do? As I've shown you, you assign front to current, then get the number out from that. Then I say front is equal to current next, that is front next, and then you link that rear with the front, decrement the capacity because you have removed one node, one number, and free current and return number. So this is the code for deleting a number from a queue. That is the first number which is present at the front of the queue. So here you have got the program. So you are creating a new data type. I'm assigning front and rear here, circular, and capacity is here declared. And we have got these prototypes: make circular queue node, enqueue, dequeue, print queue, and menu function. And init, because we are writing a menu driven function to do this, init queue to initialize the queue. Here you have got print queue. So I'm going to print. If the capacity is 0, I say it is empty. Otherwise, I get the front. And so as long as I print the first number, then get into this loop as long as current is not equal to front. Otherwise, it will go circularly. So I go on printing the content of the current till I come to the front. So that is going to help to print the content of the queue. So this is one more function to initialize. So front and rear are null and capacity is equal to 0. So thank you. Try this, write these prototype functions, write those functions, and implement your circular queue, linked queue, circular linked list queue. Thank you.